Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to today's edition of Slope and Parallel and Perpendicular Lines. Really, one thing you need to recall is that slope is just how steep a line is. And slope is used in your everyday life, your pitch of your roof, the grade of a road, the grade of a wheelchair ramp. In Northwest Missouri, there's a college in Maryville, and some of their ramps are not wheelchair accessible because they're too steep. So it would not be safe. So slope is everywhere. You might notice that the pitch of the roof as far as you go north becomes steeper than what you might see in, say, Florida versus Minnesota. And that would be because of snow. So slope is very important. And we do need to understand how it works. And therefore, that's one of the reasons why we do a lot of math with it. But when we look at slope, we need to understand the difference in the four ways it can be done. Because each of these lines has a slope. Okay? We never use the word no slope. But we read left to right. So if we were to start on the left side of this line and work to the right, we would be going uphill or up. So this is a positive slope. As we go from the left to the right side of this one, we would be going down. So this is a negative slope. Okay. And on this one, we'd neither be going up nor down. In fact, if you were to sled on this, it would be absolutely zero fun because your sled would go nowhere. So this is a zero slope. And this is just going straight down. This is actually something that is not a function. The other three are functions. Not that we're worried about that in geometry. But think about sledding. Let's say this were 2 miles tall. If you were to try to sled down this, you would not do well. And this slope happens to be undefined. It is so steep, we cannot tell you how steep it is. So if you need a way of remembering it, zero fun, sled of death. Okay? Make sure that you have the idea between whether it should be positive, negative, zero, or undefined when you look at it. So usually they're going to give you 2 points, an x1 and a y1. The subscripts just mean whatever, like your first x or your first y. So this would be my second x and my second y. So it's not quite like in science class where you have H2O. I mean, they're written at the same height. This is just numbering them so that you can keep them straight. It's like saying, hey, this is my starting point, this is my ending point. So one thing that you can do with slope is you can, so when we talk about slope, we use the letter M so that we don't have to write the word slope every time. And it's the rise over the run. Okay, so if we come back up here, we start left to right. So the rise over the run. So see how we'd have to go, starting at the left, we'd have to go up and over. Here we'd have to go down and over. There is no up, we just go over. There's a lot of up or down. Am I going up or down? I don't know, because I don't know where left is, I don't know where right is. So you can actually just count your squares, okay? Whatever you go over, how many spots you go over, see this line? It kind of means the word over, rise over, run, okay? The other thing that you can do to get your slope, sometimes they call it, if you're one of those people that like science, delta y, which means change in y, over delta x, which means change in x. You can do y2 minus y1 over x2 minus x1. You can even do y1 minus y2 over x1 minus x2. Just if the, see how the number ones come first and the twos came second here, or the twos first and the ones second. You can do any of those. You just have to pick your favorite. So we can actually just count if we want. Okay. And remember, when we count, we make sure we work left to right. So here's our two ordered pairs, and we just want to know how steep the line is. So option 1, over 1, up 2, 2, 3, 4, down 2. Okay? So we always work left to right. So we would have to go down 1, 2, 3, 4, down 4, right? And over 1, 2, 3. Okay, so we went down 4 over 3. Down 4 over 3. You probably learned this formula in junior high, and if you're in the state of Missouri, I believe this is on the formula sheet. So you can also do y2 minus y1 over x2 minus x1. And then just to prove it works the same way the other way, 2 minus negative 2 over 1 minus 4, 4 over negative 3, positive divided by negative is a negative, still the same answer. So we have 3 ways that we can look at that, and we are able to find the slope. So you can count, you can do a formula, it's up to you which way is going to work for you in that scenario. Okay, so here I have drawn 4 lines. We're going to go ahead and give them some names. We'll call this one L, this one M, this one N, and this one, I'll just call that one K. Cursive K. I don't know if you know cursive or not. I made my M's, I should have made my M and my N a little more cursive-y. Okay, so let's just go ahead and get the slope of each of the lines. So let's go ahead and start with line L. I notice line L starts at 4, 3 and goes through 1, 7. So I'm just going to count it up 1, 2, 3, 4 over 1, 2, 3, 4, 5. So the slope of line L was up 4 over 5. So I used L as a subscript so I knew which one I was talking about, and I've got a green mark on it here. It's supposed to go through that a little bit better. There we go. Okay, now let's do the slope of line M. Okay, so line M, looks like we go through this point and through this point. So we've got 1, 2, 3 over 1, 2, 3, 4, 5, 6. So 3 over 6, we'll reduce that to 1/2. Okay. And now we're going to do the slope of line K. So it looks like we go down 1, 2, 3, 4, 5 over 1, 2, 3, 4. So anytime they're on grid paper already, I just like to go ahead and count. But if you want to use the formula, by all means, go for it. And we still need to do the slope of line N. Okay, it does not quite go through 1, 7. I'm just making sure you see that that was off, because it's definitely above. But 2, 6 and 6, 1. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So we went down 5 over 4. Okay, so think about it this way. Line M and line K, they both went down 5 over 4. So they would repeat again. Are they ever going to get closer together? No, they're not. K is parallel to N, and the reason is because their slopes are equal. So that's actually a way you can use to check to see if lines are parallel, is you just check their slope. Okay, what about anything else you notice? Are there any other parallel lines? These are eventually going to come together, right? Okay. Anything else you notice? I notice that these come together at a nice, perfect 90-degree angle. And I'm using my little, actually it's what I use to draw straight lines. It's actually just a mirror. I'm using that to check this time because I wanted to show you. Definitely not the case here. They are definitely not meeting at a 90-degree angle. I could bring it in from this side. We can see it's not a 90-degree angle. So how can I know it's a 90-degree angle? Well, let's check out these slopes, 4/5 and -5/4. Some of you might just go, oh, well, one's positive, one's negative, one's 4/5, the other's 5/4. You're exactly right. The other thing we can do to check is we can say that their product is -1. So that's two ways you can check, is that one's upside down, one's right side up, right? Okay, so line L is perpendicular to line K. L is perpendicular to K because the product of their slopes equals -1. So if you check your slopes, you can actually find out a lot about how lines are related. And eventually we'll use it to find out how shapes have information on them. Okay? But, you know, you can also just visually see it. So keep in mind, if you're going to have perpendicular lines, one has to be having a negative slope and one happens to be having a positive slope. Unless there is one exception to that rule. And that is one has a 0 slope and one has an undefined slope. We can't multiply those and get -1 because you can't multiply by undefined. Okay. Now I'm going to kind of develop something with you, so please hold on to that fact. We just said that slope equals y2 minus y1 over x2 minus x1, right? What if I said, hey, the slope equals 3 and one ordered pair is 5, 7. Okay. 3. I don't like fractions, so I'm going to drop that fraction. So I multiply to the other side, right? You can also kind of think this is over 1, so you're cross producting. I'm going to be lazy and I'm going to stop writing the subscripts because I don't really care about the subscripts at this point in time because I don't know another ordered pair, so I'm just going to write distribute, add 7. Now we normally see it like this. That's the equation of a line. It's going to pass through 5, 7. Like if you start, we'll just come in here. Y equals, I said 3x minus 8. We'll graph that thing. Okay. Let's double check. Does it go through 5? Oh, it does go through 5, 7. So we just used a point and a slope to get the equation of a line. Okay, if you'll notice, the point is right here and the slope is right here. So in the state of Missouri, I know you have this on your formula sheet, and it says y minus y1, see how they just dropped the subscript of the 2, equals slope x minus x1. So it's the same thing I've written here, just in variable form, and they dropped the subscripts. This is point slope form. And on the Missouri EOC formula sheet, you should find it in the left-hand column towards the top of that list. And right below it, you will see y equals mx plus b, which is slope-intercept form. Which is what we have right here, slope, y-intercept. Okay, point, there's our point, there's our slope. If you have a point and a slope, you have an equation of the line. You just have to substitute into the formula. The state of Missouri doesn't even make you memorize the formula. Now, if you're going through calculus, you're gonna need to eventually memorize that formula. I will tell you, I have my calculus students use that formula on a regular basis. So what does this have to do with parallel and perpendicular lines? Okay. Find the equation of the line parallel to y equals negative 3x plus 2 and passing through 8, 1. Oh, okay. So negative 3x plus 2 would start at 2 and go down 3 over 1. I'm just making a rough sketch. Okay, but 8, 1 is nowhere close to that line. But I need a line parallel to this, but going through that. I need to be clear over here. So why did they tell me what I was parallel to? Well, I needed a slope because I have a point. All I need is a slope. So if I'm parallel and they had a slope of negative 3, my slope is negative 3. And now I'm going to go y minus my y value equals my slope, x minus my x value, right into point slope form. The y goes with the y, the x goes with the x. The slope is your distributor. Okay, then we're just going to practice a little bit of algebra. We're going to distribute and get y by itself. So y minus 1 equals negative 3x plus 24. So when I add the 1 over, whew, I'm glad I did not graph this one. I don't want to go up 25 squares, do you? Okay, what if they changed it to perpendicular through 3, 5? Okay, so 3, 5 is going to be somewhere like right in here, and we want to be perpendicular. Okay, so again, y minus my y value equals my slope, x minus my x value. I need my slope. So if they were going downhill, we need to go uphill. If they were doing 3 over 1, we need to be doing 1 over 3. Okay, we've got this. I know it's a fraction, it's fine. y minus 5 equals 1/3 times x. What is 1/3 of 3? Right, 1. Add your 5. There we go. So when they name them, they don't just randomly name them. They really do, sorry, mathematicians are not super creative. Point slope form is because you have a point and you have a slope. Slope intercept form is because you have a slope and you have a y-intercept. So based off your information, you can utilize the two forms as needed.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.